Thank you very, very much. I'm Adrin. I've been working on this project, but I mostly would like to talk about pickle stuff. It's always fun to see how bad something can be. It's great, but not bad, insecure. Bit about me. I got my PhD in bioinformatics. But it was machine learning in bioinformatics. I forgot the bio side. Ended up doing ML consulting. Ended up working like as somebody who does algorithmic privacy and fairness. And most of my time I'm doing open source, either working on scikit-learn or fairlearn, or these days a lot on SKOPS. So let's jump into it. Let's have fun with pickle. What do you think like this would do? I'm loading a byte array with pickle. It's just like a simple byte array. What it would do is that it returns 0. So if you put that in a variable, it returns 0. But it prints something in your console. And it's not like a Python print. I'm calling, it's a POSIX call. I'm calling like echo something. So this simple, just loading this byte array does something that you definitely do not expect loading pickle should be doing. What this does is that it relies on OS here being available, and of course it's available. You could try to circumvent that. The pickle machinery allows you to subclass unpickler, and when you do pickle load, you're basically instantiating the unpickler, and then like you read the file and you do whatever you want. And a method which you can override there is find class, and here you can have something like is it safe? If it's safe, sure, return that. Otherwise, raise an error. It would make, so if you have like a custom in-house loader that you get a lot of pickles from around and you're loading them, it would be a good first line of defense. There are a bunch of things that eval, exec, these are the things that you probably don't want your pickle to be doing. The issue is here, this is gonna be in your globals. Like in Python, you have this thing globals that like stores everything that is like available to everybody. While loading pickle, you can modify globals. So what you can do is that you have a really nice, nicely crafted pickle file that changes the values in this thing and then loads what it wants to load and does what it wants to do. And there are like attacks that can show that even if these two are two different processes, like you send to a different process to check something is valid or not, you can like even modify that. Like there are very sophisticated attacks. We're not going to go through those today. So because of the way that pickle works, at some point, and this point is like quite in the past now, Python used to have this thing like safe for unpickling and safe constructors kind of thing that like you would be like, no, these are safe, but then very soon people realized that no, they're not. So they decided to just like remove that whole thing. That was removed for Python 2.3. And after that, we know pickle is not safe, and everywhere that like there's a pickle, you should have this warning that do not load any data from any source that you don't trust. So how does pickle work? In short, you have these three things around pickle. You have the pickler, you have the unpickler, and then you have the instruction set and the pickle machine, and like basically your opcodes. So when you're loading pickle, you are running code. It's not like you're loading JSON. You run code, and at the end, you would have a variable like in that machine, and you return that variable. That's like how like unpickling works. For most objects, what is important there is like how does pickle know like what should I store and how should I load? The two most important methods would be getState and setState. These are like two of the magic methods for like Python pickling, and let's have a little bit of fun with that. Here I have a class. The only thing that getState does is returns a dictionary, and in setState, whatever dictionary I have, I just set the attributes on self. So now I dump this and then I load it, a completely empty class, but once I load it, I would have this thing. So you could do a lot in your getState and setState. And if you look at the, like you can try to look at like the pickle and you can see that, yeah, like here I have like a class from module main. And then here I'm setting this A, it's 42, and I pass that to setState. That's how like it's done. And I can save this and load it. It works. This object that I loaded does have that attribute, but it works. But does it really work? Let's try to load that in a different kernel. It raises an error because as you see here, it tries to import C from main, and then of course you don't have it. That's why you can't pickle classes that you just have in like your kernel now, and that's why Cloud Pickle exists. Like with Cloud Pickle, you can like pickle these things, but that means that you're serializing code, so even it gets even worse. So the next one, which is the real evil one, is reduce. Up until now, we have assumed that like the constructor is a normal constructor. The especially the new method, like the dunder new method, is like a normal new method. We haven't overridden that. But if you do, then you would have to implement reduce. It returns a tuple of size up to 6. The first 2 are the mandatory ones. The first one is a callable that is supposed to be called to construct the object, the initial like value of the object before like the get set state. And the next one is a tuple argument to pass to that constructor. This way, this is how everything in Python can be pickled and unpickled. If you write a custom C extension type that you want it to be pickleable, you implement reduce for it, and you call your constructor, like it works. What this means, pickling, like here I can have like whatever I want. So in reduce, I could print something, and if I look at it, I see that from built-ins I have print, and I'm printing something. And if I load it, I get that same thing. But so because the way it works is my constructor here is print, and I'm passing a string to print. I'm telling pickle that like you need to call print to construct my object. Well, you could call a lot worse methods here rather than print. So like you could do like whatever you want. Here, for example, I call a system call and I write a file. And if I unpickle that, it writes the file for me. Just like the fact that I load it, like I don't see anything, but the side effect of that is that I just wrote a file with an arbitrary content. So I get a pickle from somewhere, I load it, and you can add this thing at the beginning of your pickle. Like pickle doesn't constrain you to have like only one object. So you can have this side effect and then return a legitimate object, so the user wouldn't notice that there something odd happened, but something is modified like on their system. It can be as bad as you doing a reverse tunnel to a remote server that you want to have. And there are like a lot more attacks, like a bunch of like attacks are like on the like category of denial of service, like unhandled exceptions, protocol downgrades. Like you have different pickle protocols, you can like play around with them. But there are also some weird stuff. Like there is an opcode DUP. It duplicates the top, whatever is top of the stack. The pickler never produces this opcode, but the unpickler and the pickle machine understand this opcode. So one thing you could do, you can have like an unpickler that just like refuses this, because like if you have like DUP in your opcodes, like somebody has done something funny with your file. And there's a lot of like other like parser abuse and stack corruption issues there. Any questions up until now?
Adrin, well, when the new object in Python is constructed, the dunder new method is invoked. How dunder reduce method is linked to this in this chain? Because when you call and exploit it, what is the sequence that is executed?
So if you have a new method that has an argument which is mandatory to be passed, you need to have a reduce method which returns the new method as the constructor and whatever is needed to be passed to new as the arguments that are passed to the new. That's exactly like the only two required, the two first members of that tuple that is like 6. The first one would be your new method, and the second one would be the arguments to that new method. So if you have like a kind of a custom fancy new, then you probably also like need to implement reduce. There's like also reduce X. The pickle machine here is a little bit more complicated than like what I'm presenting here, but with just reduce you can do that. And it's the same, so there's no difference between new and if you have a C extension type, for example, if you write code in Python, if you have like your fancy constructor, then you would have to have reduce. The way Python, I don't know like how much you know Python, but the way Python generates C code for your kind of like Python looking code, the way that works is that if I have a C extension type in Python and if I have a C constructor, if I don't have a C constructor, it generates a reduce for me. That's how most Python classes can be pickled. But as soon as you have a custom constructor in Python, it does not generate the reduce for you because it doesn't know exactly how. Then you have to implement that, otherwise your object cannot be pickled. All good? So some of the things we could do is we could look at like how this pickle looks like a bit better than just looking at these like opcodes. You can try to generate the AST of the code that would run to generate the object. For example, here the thing that I'm dumping is a list 1, 2, 3, 4, and then here I know that I'm storing something in this result that I am returning at the end, and the values are it's a list, and the elements are these. Looks pretty benign. I could look at this and be like, yeah, sure, I can load this. Looks safe, I guess. But note that in order to do that, I already called load. So, and then let's do that with this class that we had up there. And when I do that, I see that it is calling something like from module POSIX. If I was in Windows, it was probably like loading something else. And then it is calling system and then echo something. So I look at this and I know something shady is happening. And then it puts that into this, and then it copies that into this, and it returns that. And that's how like it works, because like these intermediary variables, you can have as many as you want when you generate your pickle file, like, and some of them you can just ignore. There is no tree structure per se, which is also helpful because if you have pointers between things, that's why not having a tree structure kind of helps. You just have a bunch of objects, and at the end you construct what you want to have. So let's. Oh, so there another thing that like helps is this library called Ficklink. It also has this. You can call it, and you can pass it a pickle, and it gives you the Python code which would generate the result for you. You can look at it. It's nice. You can investigate some of them, and like if something bad is happening, you can like pretty easily spot. But let's say like something like a more realistic kind of use case. I have a logistic regression. I dump that, and let's look what Ficklink would give me. The results would be a little bit longer with a bunch of like byte arrays, and you don't necessarily like. It's not easy to tell now if this simple pickle file is safe or not. So up until now, everything was like completely like library agnostic, applies to all Python. But me being one of the maintainers of scikit-learn, we're like, okay, what can we do for users of scikit-learn? So now we're going to talk about some of the things that we've worked on in order to be able to persist mostly scikit-learn objects. You can persist other stuff with it too, but our focus is like scikit-learn objects. Any questions up until now?
Wait. Sorry, who's having the question? Yep. I was just wondering what happens with joblib format. We use that for these models and stuff.
For most cases, joblib is pickle. There are some optimizations on joblib for like if you mix like joblib with Loki and like or like Dask, like all of those things, like it can be much faster than just using pickle. But there's no pickle vulnerability that does not exist in joblib. And there are more vulnerabilities in Cloud Pickle that exist in Pickle. If I'm not mistaken, some of the stuff that like in the older days were only in joblib, like especially like very specific to numpy arrays and stuff, in the modern Pickle protocols, they have become obsolete because modern Pickle does the same thing. Cool. So we started working like, putting this work in scikit-learn itself would be not that easy. So we started like a separate library, called it, I thought I'm calling it SKOPS. People ended up calling it SKOPS. Sounds more fun. Fair enough. And apparently it's also like an evil character from anime or a video game or something. Happy coincidences. It has this like SKOPS.io. It exposes pretty much the same protocol as Pickle. You can load and dump objects, except that most things we're like, we don't know this thing, we can't load it. And the user has, it's not like up to the library. The user has to be explicit, like they're like, which is also like in line with the scikit-learn philosophy that explicit is better than implicit. It is annoying sometimes. User has to do more, but they know that they're what they're doing. And in this case, I am supposed to be loading main.d. Definitely don't know that. Definitely not doing it. But you can say like, I actually do trust that, and it loads it. Or if you really, really trust the source, like it's yourself, then you can say like, I actually trust this file, load it, and we load it. Let's look at some examples of dumped files. So here, I have a class C. It's from module main. So the issue that if you do not have this C in your main right now, loading would fail. It failed in Pickle. It would fail here too. Like no difference there. And then the rest we call getState and we save that, but we do not call reduce. So if you have like some fancy reduce, it just doesn't work. Loading them, therefore, like loading them doesn't run those codes. If I have, for example, this one, this was a little bit more shady. It was doing things, and you see that like here, I just don't have any of those shady stuff because I'm just like not calling reduce. But if I look at the linear regressor one, it gets a bit like it's more complicated. My schema does include a lot of stuff. Sure, it's linear regression from scikit-learn. I call getState. One big difference is that if I encounter a numpy array, I don't bother with trying to store it my own fancy way. We call numpysave with a catch. Oh no! I closed my Firefox. Does anybody know? Is it there? Yes, it is there. We recovered from disaster. Where was I?
Adrin, and what is the content of the of this npy file? Is it a reference or what is inside? Because the CLFs, when you export it, when you pickle it with scopes, you said that this the numpy array, there was no content. It's referring to a file.
Yes.
Yeah.
So
And what is the content of the file?
So here, like the schema. So basically, the SKOPS file is a zip file, and we just like in the schema we store the name of the file that includes the data for that thing. And here you have a bunch of NPY files. This is what we load. Like we just like call numpy load, and then we attach that to the variable that is supposed to be attached to.
So that's there's an array, I guess.
Yes, in this case, like it's an array. If it's a numpy d type, we just like use numpysave. We do some hacks. For example, an attribute can be a d type. How do I store a d type? We didn't bother with like finding a way to store d type. Store an empty array with that d type, and then load that array with that d type, and like read the d type. Like that's like kind of like a hack that we're doing around that. There's a catch that numpysave, if there is a d type object in your numpy, it falls back to pickle. So what we do here is that we specifically pass allow pickle false, and if there is an object d type, we kind of assume that kind of like a list of Python objects, and you do your recursion. You're like, please now try to persist this list of numpy objects, and we try to persist those like objects. The same with numpy load. The good thing with numpy load is that by default allow pickle is false, very reasonably so. So if you have like a numpy with d-type object, you do numpy.load of the numpysave, it fails by default because there is a pickling happening in between. And then you can just load it. In this case, I don't have to pass any trusted values because we have tried to have for most of the sensible scikit-learn, numpy, scipy types to have them like kind of trusted by default. Again, the same issue happens if you have some malicious code that before running this is changing those global variables and trusting things that shouldn't be trusted. Then you're running malicious code, but loading the file doesn't run those codes. So because when we load the file, we just, I'll talk about that later. That said, like if you do have a malicious library installed, you're out of hope. Because if you have a malicious library installed, running Python runs arbitrary code. Just you run Python, you run arbitrary code. So we assume that you do not have any malicious libraries installed. And the way it works is that we call new. So if you have a fancy new implemented, it just doesn't work. And for the few objects in scikit-learn that they do have like this fancy new, instead of like, we try not to like rely on the on reduce, we just like have custom classes that save and load those objects. So if you have custom objects, this format wouldn't work for now. And this is kind of the limitation. Like you don't work for everything, but at the same time, it's like you get a little bit of security out of it. We only work with like getState, setState for pretty much everything. And we have like special treatment of like certain types like dict, set, list, tuple, type, slice, all the like numpy, scipy, ufuncs. There are some C extension types that like require calling the reduce. We do that, but we only do that for those classes. For everything else, we just don't. And the loading process, we load everything from the schema file into memory without constructing anything. Then we investigate like what we are going to load, then we load. So any attack here would be any JSON load attack. So if you have a vulnerability on JSON load, then sure, it's vulnerable, but otherwise it's okay. And then we create an instance with new, assuming there's no funny constructors or like arguments there, and then we call setState. If you want to try things, we also have an online thing where you can, if you're using the latest scikit-learn version, you have a pickle file, you can load it here, you can convert it, it gives you the converted file. You can definitely uncheck that if you don't want us to have a copy of that file. Is it safe? No code is 100% safe. Would I use it? Yeah, we have been using it. It works, it's nice. Is it fast? Definitely not, that's not the goal. The file, like the latest released version, the zip files can be also pretty large, but now we're gonna do a release. We expose the compression arguments to zip so you can compress your zip files, like that helps a lot. There are some raised exceptions. Make sure, like, one of them is that, like, if you try to load something that has untrusted stuff, like, we raise an exception. So if you consider that an issue, you definitely need to put a try catch around it. You do have the same issue with very large objects. We are loading numpy arrays. Like, if there's an issue with numpy load, you have those issues here. Some notes, I mentioned that if you have like custom new, it wouldn't work. It does support not just scikit-learn stuff, like we do support xgboost and lightgbm models because xgboost and lightgbm, their getState returns a byte array and their setState uses that byte array to load the model. So we just store the byte array. At least xgboost has a custom format that allows you to load between xgboost versions. We don't use that here yet. And there's an argument like it would be nice maybe if we do. The roadmap, like we have things like there are more things that we could trust by default, like from numpy, scipy, scikit-learn. So there are cases that you save something that is completely legit. If you try to load it, you would have to pass some custom trusted arguments there. We don't do any memory mapping. So if you're doing parallel processing and you load a bunch of files, for each one of them you're loading the file. Whereas with numpy, you could pass this thing that like it should be kind of memory mapped, which means that if you have multiple processes, like they all like point to the same like data, so like you don't load them multiple times. And we would need to work on a kind of a public protocol that would allow third parties to support like more custom types and have a way for them to register how we should like load and save them. We did not rush to do that because we don't know how to do that in a safe way yet. And we need your help. Please try to break things, report bugs. I'm sure there are vulnerabilities. It would be really nice if people who are not us find them and report them and we try to fix them. And thank you.
Thank you very much, Adrin. There's a question asking you, does SKOPS also help with loading a scikit-learn model trained from version X using version Y? Are there any future plans about it?
No. So what we do is we call getState setState, which is exactly the same thing as pickle does. And the reason you do get a warning when you try to load a model in a new scikit-learn version that is dumped with an old scikit-learn version is that the getState of scikit-learn injects the version of scikit-learn with which it is saved into the dictionary that is saved, and load checks if that version is the same as what it is now, and it gives you a warning. For a lot of models, it should actually raise, because if you load one, it just doesn't work. There are no future plans because, so you do have, for example, for xgboost does that, but xgboost is pretty much one model. It's a tree. It's doable. You can do that. With all deep neural networks, you can do that. It's a network. You save the architecture. You have the activation functions. Like, it's easy to do that in like across versions. But in scikit-learn, it's an arbitrary Python code. I move my loss. For example, in our gradient boosting, we would move the loss module from this private place to that other private place. And now you load it with a new scikit-learn version. It is trying to load something that doesn't exist anymore. The same goes with like the logic inside the model. So supporting that is in theory doable, but it would require a large team dedicated to just do that, and we don't have the resources.
I don't see any other question here. No, does here anyone have live?
Maybe the last question.
Sure, of course.
Let's assume I have you mentioned the ML model. So let's assume I have loaded an object which points to the different models. Let's say it could be FST, it could be ONX, which are preloaded in the memory. And now I would like to share this part of memory between the processes because I don't want to load the same model multiple times. Is the question. So is it possible to export this model by any address in the memory and then load it in other processes? So for example, loading a model would cost me 2 GB of RAM. If I run 5 processes, it's already 10. So I just want to load it only once in the master process and share it across.
Not 100% sure, but I'm almost certain joblib has backends that allows you to do that.
Which one?
Joblib. So joblib is the backend that we use for like kind of for parallelization in scikit-learn, and joblib itself supports different backends. And I know that this is an issue that already existed, and they already have solutions for it there.
But probably for pickable kind of objects.
Things need to be pickleable.
Yes, but that's what I mean. So if the model will just point to the different pointers to memory which are loaded.
Then you need to do low-level
Yeah.
like shared memory objects
Yeah.
like in Python. I personally haven't done it, but I'm pretty sure you can do. And definitely like SKOPS is not going to be the solution for it, but almost certain you can do that.
Okay, thank you.
Any burning last question? Yeah.
Thanks for the talk. For your conversion service, how do you do that? Is it just a small Docker environment which you throw away after each conversion, or how do you make that safe? Converting from pickle to SKOPS format?
It is, so that's on the infrastructure of Hugging Face, and it's technically like what in Hugging Face jargon you call a space, and each space is its own Docker. You launch a new one, you do whatever you want to do. It's kind of its own isolated space, so that's fine.
So if there's no other question, thank you, Adrian,
Okay.
very much.